Okay, so moving on to the next part. When you multiply real numbers, remember from the warm-up that we did before, you're going to take top times top, bottom times bottom. But anything in the numerator can always be canceled out with anything in the denominator. So as we look at this, when we look for canceling things out, we can only simplify things that are being multiplied together. So we need factors. And right now, if we look at this problem, we don't have factors. We have a binomial times a binomial and a binomial times a trinomial. But we can factor these, and so that's what we're going to do. I'm going to factor this first, the a squared minus 9. That's the difference of squares. So that's a plus 3 and a minus 3. Okay. And on the bottom, I notice that I can factor a 3 out. So then that's a minus 2. On the second part, I have a squared minus 4, which is, again, the difference of squares. So a plus 2 times a minus 2. And then on the bottom, a squared minus a minus 6. This is where we need to get quick about doing the factoring, like what we were talking about, because we need to know what multiplies together to give us negative 6, but adds together to give us negative 1. And so negative 3 and positive 2. So a minus 3, a plus 2 is going to do that. That'll give us this piece here. Now, these are all factors. Factors are things being multiplied together. So we have 3, we have a minus 2, we have a minus 3, a plus 2. On the top, we have a plus 3, a minus 3, a plus 2, a minus 2. So we want to cancel out anything that's the same. So a minus 2 and a minus 2 cancels out. A minus 3 cancels out. A plus 2 cancels out. So look at how beautiful that is in the fact that when you're finished, on the top, the only thing you have left is a plus 3. And on the bottom, all you have is 3. And that's that. Now, do not make the mistake. Some people think that they could cancel out those 3's. Is that possible to cancel out the 3's? And your answer should be no. And let me show you just real quick in case you thought you could. Let me show you. Number 1, this is one whole factor. These are being added. So that's one whole factor. So it's not 3 is not a factor on top. But a way to think about it is if you're in doubt, if you just plug in some numbers. For example, if I take 1 plus 2 over 2. Okay, 1 plus 2 over 2 is 3 halves, which is 1 1/2, right? If I thought that I could cancel it out, then 1 plus 2 over 2, if I thought I could cancel it, then I get 1. But again, remember, these aren't the same, so you can't cancel that. And that's because those are not factors. Okay. Next is division. When you divide, you're going to multiply by the reciprocal of the second number, of the denominator, the second piece here. So as we look at this, I'm going to change this to a multiplication problem because I'm much better at multiplying. And or I can multiply like what we just did. So here I have x squared minus y squared. I'm going to factor that right away and say that's x minus y and x plus y, just because make it a little bit easier, over 9. On the bottom here, do you recognize that this is, or this top here, do you recognize that that is going to be x plus y times x plus y, or x plus y squared? Because these are both perfect squares, and this is 2 times each of those. So now I'm going to flip and multiply. So I'm going to flip this second one. So I'm going to put the x plus y on the bottom and the x plus y on the bottom. And I'm going to leave it written like this for a minute, just because then that way you can see that our x plus y's cancel, and our 18 and our 9 will cancel out to be 2. Now, once we do that, I want to take a step here, and I have x minus y over x plus y. Okay. And then, and I have a 2. Oops, sorry. So I have 2 times x minus y, x plus y. And that's your answer. Next, we want to find the least common denominator. Remember, the least common denominator is going to be the first multiple that they have in common. So if I had this, if this is what I had, and I wanted to change it to this, what do I got to do to get 2a to become 6ab? Well, I got to multiply it by 3, and I've got to multiply it by b. And the point of this is to realize that whatever you do to the bottom, you have to do to the top. So we're just kind of reviewing old rules. So then this would become 9b over 6ab. On the second one, number 10, if I look at this, okay, I have x plus 1 over x plus 2, and I want it to become this. And again, I'm going to factor it so I can see what I'm dealing with. I have x and x. What multiplies together give me 8, but adds together give me 6, and that should be positive 4 and positive 2. So I can see that I have this factor that's the same. So the factor I'm missing is the x plus 4. So that's what I'm going to multiply. I'm going to do x plus 4 on the top and the bottom. Okay, so then that leaves me with, on the top, I'm going to have x plus 4 times x plus 1. Or if I want to distribute it out, I would have x squared plus 5x plus 4 over that x squared plus 6x plus 8. And again, if I write it like this is one whole factor, and this is one whole factor because they're being added together. And the factors have to be multiplied. So there's nothing that could cancel out there. Adding or subtracting rational numbers. In order to do this, in order to add or subtract numbers, if you think about the warm-up, we have to have the same denominator. So as I look at this, my first thing is I need to make sure that denominators are factored. So this one here is the difference of squares. So this is x plus 1 and x minus 1. So to get my denominators the same, I already have x minus 1, so I need to multiply it by x plus 1. Whatever I do to the bottom, I have to do to the top, or the numerator. So then this leaves me with x times x plus 1, so it's x squared plus x plus, and then the 2x plus 3. And then my denominator is this x plus 1, x minus 1. Now, I'm going to simplify that, of course. Combine like terms. And it leaves me with x squared plus 3x plus 3 over x plus 1 times x minus 1, or you could say that's x squared plus 3x plus 3 over x squared minus 1. And on the numerator, there is nothing to factor because there's nothing that will multiply together to give you 3, but add together to give you 3, so we're done. On the second one, if I look at each of these, again, the first thing I need to do is factor the denominators. So here I have x plus 3 times x plus 3, or x plus 3 squared. Here I have x plus 3 and x plus 2. So that means that I need 2x plus 3's over here. So I've got to multiply this one by x plus 3 again. So if I do it to the bottom, I have to do it to the top. And on this one, I have an x plus 2, so I need to multiply this one by x plus 2, top and bottom. So I'm going to go ahead and distribute. I'm going to take x plus 2 times x, which gives me x squared plus 2x minus, and then I'm going to multiply these two things together. So I have x squared minus 3x plus 2x is minus x minus 6 all over that x plus 3 squared times x plus 2. Okay, and then I'm going to simplify. So I'm going to combine like terms on the top. So I have x squared minus x squared, so those are going to go. I have 2x minus x to be x. I have x minus a negative 6. Oops, sorry. 2x minus a negative x, so that's actually 3x. And then I have minus a negative 6 to make it positive 6, all over x plus 3 squared times x plus 2. In the numerator, I'm going to notice I can take a 3 out. So I have 3 times x plus 2 over x plus 3 squared times x plus 2. My x plus 2's cancel. That's going to leave me with 3 over x plus 3 squared. And that's my answer. Oops. All right, now we're dividing. And so here, when I approached this, there's a lot of ways you probably could do it, but I looked at my numerator and my denominator each separate. So I'm just going to focus initially simply on this numerator, and I'll put it in this burgundy color. So what I have is a plus 4 over a plus 4. Now, in order to add that, I have to have the common denominator. So I need to multiply, this has a denominator of 1, so I need to multiply this one by a plus 4. So then what happens is I have a squared plus 4a plus 4 over a plus 4. Okay, and as I look at that, you can see that this is a plus 2 squared because it's the sum of the perfect squares. Now, on my denominator, I have a minus 4a plus 4 over a plus 4. And so I need to multiply this one by the a plus 4 so that they have like denominators. So then that's going to give me a squared plus 4a minus 4a minus 4 if I subtract both parts, all over a plus 4. So then this is going to provide me with a squared minus 4 over a plus 4, which is the same as a minus 2 times a plus 2 over a plus 4. Okay, so now I've simplified my numerator, I've simplified my denominator, kind of feel like I have a mess going on, but what I'm going to do is I'm going to remember a couple things. Number one, division is multiplying by the reciprocal. So I'm going to, instead of having a division problem with the fraction in the numerator and denominator, I'm going to multiply by the reciprocal of my denominator. So I'm going to take my burgundy one, which is the a squared, a plus 2 quantity squared over a plus 4. And then I'm going to multiply it by the reciprocal of the purple one. So I'm going to multiply by a plus 4 over a minus 2 times a plus 2, okay? Because now that I have it into multiplication, now what I can do is I can go ahead and simplify. I can take out the a plus 4s. I can take out one of the a plus 2s. So then what I'm left with is a plus 2 over a minus 2. And then that's my answer. It's a lot of work. But if you keep following the rules, you're going to get better and better at factoring, and just be very careful. Okay. The next one, dang it. Okay. The next one, because I have negative exponents, I'm going to remember the rules about that and what that means. So what this is then is this is 1 over a plus 1 over b cubed over a over b squared plus b over a to the 4th. Okay, so I have a fraction inside a fraction, and so I'm going to work to simplify the numerator and the denominator. So on my numerator, I'm going to get like denominators, so I've got to multiply this one by b to the 3rd, and I've got to multiply this one by, oh no. I'm going to multiply this one by a. So then on my numerator, what I'm going to have is I'm going to have b to the third plus a over ab to the third. That's my numerator. On my denominator, I need this one to be multiplied by b to the squared, and then I need this one to be multiplied by a to the fourth. So then I have on my denominator, I have a to the fifth plus b to the third over a to the fourth b squared. All right, so now, just like the last one, I have a fraction divided by a fraction. So I'm going to use my rules, and I'm going to take the b cubed plus a over ab cubed, and I'm going to multiply it by the reciprocal of a to the fourth b squared over a to the fifth plus b cubed. And when I do that, just keep in mind, this is a factor, this is a factor. Each of these are factors. Okay, so as I look at that, then what I'm going to see is my a can cancel, so this becomes a 3. My b to the third cancels with the squared to become b to the first. And these, then here, so then what I'm left with is on the top, I have a to the third times b to the third plus a over b times a to the fifth plus b to the third. And I don't think there's anything more that I can do. I could distribute the a through and the b through if I wanted to, but that's pretty much the answer then, depending on how you want the final answer to look. And that would be the end of Appendix Lesson 5.